All right, good morning. Thanks so much for having me and to the organizers for making this happen. Lucas said we had very good reasons to be here for this event, and that's exactly what I'm interested in. Because amongst the topics that I'm working on currently is reasons, philosophical theory of reasons, and then hopefully eventually the logic and semantics of reason for ascriptions. I should say that I changed gear a little bit compared to my original plans. So I wanted to, relate to other talks in this conference. There will be talks on deontic logic and practical reasons, so that would have been a possibility, and I'm working on a paper on that topic. But there will be also talk like by Stephen Jablo, that's more on the probabilistic side, confirmation. That's to do with epistemic reasons. So I had to decide. I couldn't do both of them, unfortunately, time-wise. So I opted for the epistemic reasons case. So there won't be anything on deontic logic, I'm afraid. But if you're interested, I think something like this can also be done for practical reasons, and then to use that as a foundation for deontic logic. So if you want to know more about that, please ask me in the Q&A. Okay. But today it will be on epistemic reasons, that is, reasons to believe, and really more on the foundations of Truthmaker Semantics than actually Truthmaker Semantics, because a lot, I think, needs to be done before we get to the actual logic and semantics of things. So it's on the way there, and I'm presenting what I have so far. Okay. Now, reasons and reason ascriptions. So you might know that in the philosophical literature, reasons have been a big topic in the last couple of decades in practical philosophy. Okay, it's one of the dominating themes there. Okay, it's very, very important. But not a lot has been done on relating these existing philosophical body of work to the more formal side of things, logic and semantics and formal epistemology. And that's what I'm interested in. Okay, so I think this philosophical work has a lot of ideas to offer for the more formal people. And the other way around, sort of the methodology that we might have in logic and formal epistemology, I think can bring something to the philosophical theory of reason. So ultimately, with a little luck, this is going to work out, but it will also need tolerance from both sides, I should say. Okay. Now, what's fairly common to believe is that normative reason ascriptions create hyperintentional contexts. Okay, so here I use an example that's sort of tailor-made for kids' exact truthmaker semantics, where we know that P on the one hand and P or P and Q in parentheses are logically equivalent, but might well differ in terms of their exact truthmakers. And we can use that to drive a wedge between them if, for example, they show up in the argument places of a reason for ascription. Like the fact that you promised to visit the zoo might be a strong reason to drive to the zoo, but the fact that you promised to visit the zoo, or you promised to visit the zoo and you are drunk, is not a strong reason to drive to the zoo, right? That can happen. So that's hyperintentionality with respect to the first argument place, blah, blah, being a reason for something. But you also get something in the second argument place. The fact that you promised to visit the zoo is a strong reason to drive to the zoo, but it might not be a strong reason to drive to the zoo or to drive there and not watch the animals, right? So you might also get hyperintentional context in the second argument place, okay? And that's fairly common to believe that, but I don't think in the philosophical theory of reasons, there's been a lot of work on that, okay? But of course, if you're into Truthmaker Semantics, you might become interested in that. So it looks something like this, right? We have something like a reason for. We have, here we want to put a description of the reason, hyperintentional context. Here we want to put a description of an action, like in my previous slide. But what I'll be interested in more will be to believe something, or a reason to believe something, or a reason for believing something. So it will be about epistemic reasons, okay? So then we have a belief description here, but at first we think of that as creating a hyperintentional context to this place. And then we have some strength or weight, and more needs to be said about that. And that's where sort of the complications are, okay? Why this is not an easy topic, I think, personally, okay? Okay, but so when I worked on this, you know, it was easy to see quickly that this is a complicated matter. So it's good to start with some simplifications, and that's what I did, okay? So the first simplification that I want to introduce is concerns sort of the left-hand side, the reason side, as it were. And there, linguistically speaking, okay, let's think of that. You put there conjunction of, you know, propositional variables, okay, or negated propositional variables, literals, and think of each of them, each of these literals, just expressing a single state, as it were, okay? So, you know, a very simple situation, right? Then semantically speaking, what you got described here is, you know, one of Kitt's states of fusions of, you know, states. That's another state, okay? So you're dealing with single states here on the left-hand side, rather than with sets thereof that have a kind of disjunctive interpretation. Okay, so I want to simplify in that sense, okay? Semantically, this makes it less interesting, but it has the advantage that if you look into the philosophical literature on reasons, you don't get a lot of information on what they want to have in terms of something like disjunctive reasons or so, okay? That's not what they are primarily interested in, okay? In fact, they don't tell you a lot. I'll tell you in a sec that reasons are meant to be facts, so they're very firm on that. But then you ask them, are there disjunctive facts and how does this work? You don't get a lot of information. At least that's what happened to me. Okay, I honestly asked them. Okay, so let's make that simplification. Okay, the second simplification I want to make is I will only look at epistemic reasons in my talk. These are reasons to believe rather than reasons to act in an arbitrary manner. Okay. So, you know, it will really be building a bridge to formal epistemology in a sense, ultimately, because I'll be very much interested in reasons to rationally believe something, okay? Reasons for belief. And then, you know, if you look into the literature, there's also fairly common ideas how these epistemic reasons for belief are meant to work. I'll have more to say about that in a sec. But if you read, for example, Jonathan Dancy, he would say things like, generally speaking, reasons for believing that P are facts that raise the probability that P. Okay, so epistemic reasons are to do with incremental support. Okay, somehow, you know, probabilities get up if it's a reason for, okay, maybe go down if it's a reason against and the like. Okay, so we want to have some probability theory in the background, subjective probability theory, that is. So it will be a Bayesian account to some extent that I'm going to present. But this will have consequences. So it would be nice to have something like a hyper-intentional theory of probability that we could plug in here, okay? And, you know, I remember Johannes over there having worked on this, and maybe we'll hear more about that in Stephen Jablow's talk. But, you know, I will be very conservative here. So my probabilities will be just standard probabilities. No funny business there, okay? And as it happens, you know, in philosophy, we tend to think of subjective probabilities to be assigned to propositions in the sense of sets of possible worlds. The good old stuff, okay? I know now Truthmaker people might throw things at me, boo, intentions and so on, okay? But, you know, this makes it possible to use the standard probabilistic machinery, and that's what I will do. So actually, I will simplify also with respect to the right-hand side, okay? And only look at, you know, reasons for believing that P, and that P will be a proposition in the sense of a set of possible worlds, and probabilities will be what you think they are, okay? Again, you'll see it's complex enough anyway. And then, you know, I want to build that bridge, right, between the philosophy of reasons and Bayesian epistemology, if you like, okay? So this will require some tolerance from both sides, as I said. But, you know, if on the second slide, I tell the Bayesians, by the way, your probabilities work very differently than you thought, you know, I don't think there will be a lot of hope for my project to get them on board, okay? So I want to be conservative here, okay? So what I will put here on the second argument place will be believing a proposition, a set of possible worlds. And since I fixed the believing, we may only just look at the set of possible worlds, and that's it. Okay, so you'll find a good old proposition in the intentional sense here. Okay. And then finally, right? So now you see where this might be going. Okay. And ultimately, I think we'll have a nice object language, right? To talk about, you know, these epistemic reasons and what they speak for and how they relate to probabilities, okay? But then this will require, if you have a proper logic for that in the object language, you can talk about probabilities, right? And that's possible, right? And you can do that explicitly or implicitly. If you do it explicitly, you have what's called a probabilistic logic that will be part of it. And these systems exist, okay? But they tend to be more complicated than what we have when we do normal probability theory, where we have the set theoretic jargon around, okay? So, I want to avoid these additional complications, okay? Or you could leave the probabilities implicit, right, to something that's called qualitative probability, and then have something like, X speaks for Y more strongly than A for B or something like that, right? And instead of having the numbers that you refer to explicitly, you put it all into this sort of qualitative or comparative sort of expressions. And that's possible. And ultimately, I think that's where I want to go on the deontic logic side for that, okay? But it means that you then have to involve lots of considerations from measurement theory, okay? And then there will be things that show up like an Archimedean axiom, and you have to express that logically. I think that's possible with an infinitary rule, but it gets complicated. So I thought it would be a good move at first, not so much to develop proper semantics for reason for ascriptions, the linguistic thing, but rather an axiomatic theory of epistemic reasons, the things themselves, okay? So what I will really have is a relation between hyperintentional entities, okay? Namely facts and fusions thereof, okay? And here in the second argument place, I will have intentional entities, namely the contents of belief, that is sets of possible worlds, right? Contents of Bayesian belief, that is, okay? And then we'll still have the numbers, and we'll still have a lot of work to do to figure out how this works, okay? Once we have that in place, basically what I've delivered, I hope, is the things that you would put into your models if ultimately you want to turn that into a proper, linguistic story with a semantics and the logic thereof, okay? So then at least we know what the models should include. And then sort of the rest of the job will be to make the salient features of our models expressible in the object language, right? And to have some logic that tracks what's going on sort of on the semantic level. And I think that's the next step, and I think it's perfectly feasible, but first things first, okay? So that's basically the plan. All right, so the objective will be in my talk to develop an axiomatic theory of epistemic reasons for epistemically ideal subjects in the Bayesian sense. So these will be Bayesian agents, as it were, okay? And I'll start by explaining what I mean by an epistemic reason, just rehearsing sort of the ordinary philosophical literature on that a little bit. Then I'll present my conception of reasons, which I call dynamic, okay? Dynamic because on the one hand, it's to do with reasons imposing a kind of epistemic force on our degrees of belief. That kind of metaphor I want to make precise. And it will also be dynamic because reasons will be involved in rational belief change. There will be something like update or revision of belief in the light of reasons being presented to a subject. Then I'll talk about the aggregation of reasons. That's when you put reasons together, okay? Think linguistically conjunction, okay? And finally, the interaction of reasons with rational belief, because these are reasons for belief. So you want to build the bridge between the reasons on the one hand and belief on the other hand. And belief, in my case, will really be subjective probabilities, rational degrees of belief measured numerically. And then I'll draw some conclusions. I also have some slides for the full axiomatic system. If you're interested, we can go there in the Q&A. But what I'll do in my talk, I'll just pick some of the axioms and try to convey the general message, but there's really more axioms that you need to get the whole thing going. And if you want to know more about them, please let me know later, okay? All right, here's a little story, typical story, okay? So you have a person waking up in the morning. She believes that the weather will be nice at noon, okay? Clearly that's not Munich right now, okay? But think Italy. Her belief might be based on having experienced the same stably pleasant weather for a couple of days now. Okay, so she believes weather will be nice at noon. That's how she starts. But then over breakfast, new considerations become available to her. So that's belief, right? And then new considerations become available to her. These will be the reasons, okay? Like she reads the weather forecast in the newspaper, which predicts rain to arrive in the next couple of hours. That sounds more like Munich now. She looks out of the window and sees gray clouds forming in the distance, and she remembers having had the kind of headache yesterday that in the past reliably appeared to precede inclement weather breaks. So roughly speaking, everything speaks in favor of the weather being bad at noon after all, okay? So these constitute reasons that speak for bad weather. So now we have the reasons. And if taken together, they happen to be much stronger than her original reason for believing that the weather will be nice. This taking together, right? You have to combine them, put them together. That's the aggregation of reasons, okay, that we'll be interested in. And the stronger, that's a reference to, the weight or the strength of the reasons. So these reasons come in strengths, okay? And therefore, since, the reasons for believing in bad weather are stronger than the original, whatever she had in terms of original reasons, she has every reason to change her belief. And if she does so, she's rational in doing so, okay? She's right in doing so. So rational belief change being justified by the reasons that have become available to her, okay? So stories like that capture what I think is essential in the philosophical literature to normative reasons for belief, okay? So normative reason means it's a reason that supports something. Here, believing something, okay? So it's a reason in the business of justifying or support. There's also other kinds of reasons, explanatory reasons, motivating reasons, and so on, but I'll be only interested in the normative reasons, okay? So what you find in the philosophical literature about that is, first of all, these epistemic reasons are facts, like the fact that she reads the weather forecast in the newspaper which predicts rain. That might be one of the facts, okay? Or the fact that someone asserts something, or the fact that she sees the gray clouds forming in the distance or something like that, okay? Secondly, these reasons come with strengths by which they can be weighed against each other. So this is this weighing metaphor, right? Okay, so picture Lady Justice, right? And she weighs, right? Should this guy be put into jail or not? That's the kind of thing, okay? In the philosophical literature, the reasons in the sense that I'm interested in are called pro tanto or contributory. So the idea is they contribute a little bit, right? So they make things a bit more likely or a bit less likely, okay? But really, there's lots of them, okay? And ultimately, we'll have to look at them jointly, okay? And what they do, each one, is support propositions probabilistically, of course, sort of somehow in functional dependence on their strengths, on their weights, right? Now, they may join forces or defeat each other. So on the previous slide, we had something like maybe her original reasons and then reasons acting against them, right? Bad weather rather than good weather. Therefore, it's only when all of the reasons available to a subject have been aggregated, put together, that you have a full picture. And then you get something that's called the pro toto, or all things considered reason, where you took everything into account, right? Or each of the little ones, as it were. And that looking at that may settle the case in the sense that, given your prior beliefs and this all things considered reason, you might now, if you're rational, determine your new degree of belief. That's kind of the idea. Okay, so that's the story. That's the story that I want to reconstruct. I want to resemble ultimately what we have in the philosophical literature, okay? But I want to make it more precise and clarify things and systematize things and make it consistent where it's not and so on. So I'm in the business of rationally reconstructing sort of the philosophical theory of epistemic reasons, okay? Now, simplify things a little bit to get a feel for it. So say you have two perfectly trusted and trustworthy informants, capital X and capital Y, okay? And then you have two facts, little x and little y. So the little x fact is the fact that capital X asserts the proposition A. Okay, so she tells you A. And the other fact, little y, is that capital Y asserts the proposition B. Okay, so he tells you B is the case. Okay? All right, so these give you reasons. Okay, X is a reason that speaks for A, right? Because that's been asserted, and Y is a reason that speaks for B. Okay. So if this is logical space, now chopped up in terms of possible worlds, remember on the right-hand side, I'll have my intentional picture, so the good old picture, okay? Then we'll have a set of A worlds that corresponds to the proposition that A, and we have a set of B worlds corresponds to the proposition that B. And since these are perfectly trusted and trustworthy, you might think what they do is by asserting A or B, respectively, they just rule out the not A worlds and they rule out the not B worlds, okay? No funny business. And then if you aggregate them, so that will be my function symbol for aggregating the two facts. Then you get the aggregated fact, the aggregated reasons, okay, because the facts will be the reasons. Then you get the obvious thing, these are ruled out, what's left is this thing here, right? So, taking the two reasons together, it speaks perfectly, as it were, for the intersection of A and B. This perfectly trusted and trustworthy informant example I take from Tim Williamson's recent book, okay, where he argues, that this whole reason for ascription business and the additivity of reasons, reason adding up and so on, is a mere heuristics. Okay, so it's useful, but it's to some extent a kind of cognitive shortcut that we're taking here. Okay, now I take my theory, to be in the business of showing that this is not so. It's more than a heuristics. Okay, but it's a nice example. That's why I'm using it. Okay, now Tim used this perfectly trusted and trustworthy informant, but that's not the case in the real world, right? So let's cross it out. They're not perfectly trusted and trustworthy, but they're pretty reliable informants, as it were. Okay, reasonably good testimonies that you get from them, as it were. Okay, and let me put some numbers there. So let's say capital X, the one informant, is better than capital Y, epistemically speaking. Okay, now and let's say we can measure that. So roughly the A is supported, right, by capital X assertions with an epistemic oomph of 3, and here on the other hand you just get a 1. Okay, now you might think, what do these numbers mean? Currently they don't mean anything. Just give me the numbers for the moment. They're just meant to signal the one is better than the other. Okay, ultimately at the end of my talk these numbers will have a determinate meaning, a kind of nice Bayesian interpretation, I think. Okay, but currently there's more epistemic oomph that speaks for the A than what you get here. And by the way, you don't rule out not A completely, but sort of, it speaks against it. So you get a -3, let's say, and a -1 here, okay? Why do I have a minus here? Well, see later whether it makes sense or not, okay? And then, you would aggregate still, but here's something that interesting that happens, right? Intuitively, right? If you take that quarter of logical space, you have a 3 here. So this assertion still speaks in favor of that quarter of logical space, amongst others, right? Speaks for all of A, right? And this one speaks for the other half of logical space that B have, right? And in particular, that quarter of logical space. So indeed, there's a lot of push towards that quarter, right? A 3 and a 1. That's great. This was what was tracked by taking the intersection before, right? But then again, look at the left lower quarter of logical space here. You get a 3 here, right, from that fact, and you get a -1 here. But, the 3 has more oomph than the -1. So intuitively, you would expect that, the aggregation of the two reasons should still give you some sort of reason for that left lower part of logical space. Not with the same strength as that one here, but there's some strength left, right, that would also speak for that. And also for that, and with that quarter of logical space, you get a -3 and a -1 here. It should really strongly speak against that, okay? So you get a more complex picture, right? And I want to say, if you just took the intersection of A and B and ignored the rest, you would throw away lots of interesting information that we shouldn't throw away, and that I think is salient if we talk about reasons, okay? So what we are going to see is my reasons will be graded. We want to have the weights or strength of reasons, and something like what I described intuitively is going to happen. Okay, so the reasons will really be more like vectors, and vectors can push in different dimensions with different strengths at the same time. Okay, and that's exactly what's going to happen in my theory. Okay, now I'm not the first one to be driven by some thoughts like that, right? It's an old idea that reasons for belief are something like, vectors, or something that we represent in terms of vectors, namely forces, and they push you sort of, okay? And that's the idea, the guiding thought that I have. Epistemic reasons are something that impose normative force on your rational degrees of belief, okay? So this is a quote by Benjamin Franklin, the Benjamin Franklin, okay? When he was asked, so how do you make up your mind about, certain measures, maybe political measures or so, okay? And what he says is basically, let's make a pro and con list, okay? The thing that you used once to determine your partner. No, I hope you did not. It's very unromantic, right? But you get the idea, okay? So you have a pro side and a con side, and basically he puts there, the different motives. These are the considerations or reasons, okay? And they come with strength. So he doesn't talk about the numbers in his letter here where he describes how he's doing it. But, he says things like, something here on the pro side might be as strong as something on the con side, right? Then they cancel each other out, as it were. Or, two things on the con side taken together might be as strong as this thing on the pro side. They cancel each other out, right? So if you had the numbers and thought of like vectors, here just in one dimension, as it were, right? you would sum them up and see where the resulting overall vector is pointing. In this case, it's pointing towards A rather than not A. So he would go for the A, right? That's how he would make up his mind. And this idea is an old one, and I want to capture that idea ultimately, okay? So reasons seem to be like vectors. Aggregation seems a lot like summing them up, okay? But then again, right, as was rightly observed over and over again in literature, here's a nice quote by Jeff Horty, well, this is just a metaphor, right? It sounds nice, but as long as it just stays a metaphor, we're not sure that we can do anything with it philosophically or logically, okay? So we want to have something that satisfies Frege's standards of rigor, right? Where's the rigorous theory? And Jeff Horty is amongst those who said, well, you know, that won't fly. We can have orderings between reasons, but we can't properly add them up in a more serious sense of the term, okay? Now I wanna, you know, I wanna show you can, okay? So what follows is to meet this challenge to put rigor onto this kind of basic idea. There's other people who have worked on this in different ways. If you're interested, let me know. Okay, there's references. Okay, I can't go into that literature, but I can in the Q&A if you want. Okay, and the outcome will be there will be a reason that looks like this. So the reason is still the fact, but every reason comes with an epistemic force. And what I had here, this graded partition where you give numbers to partition cells, as it were, that's the force of that reason, the epistemic force of that reason. Okay. And then you have the fact here, y, that's the reason, and it has an epistemic force. It's represented by this here. And if you aggregate the two facts, the aggregation will have an epistemic force, and it will look like this, where, for example, in the left upper corner, you take the 3 here, the 1 here, you add them up, you get a strength of 4. Okay? And in the left lower corner, you have a 3 here, you have a -1 here, you add them up, you get a 3 plus -1 is 2. Something that's a bit weaker, but you know, as I said before, there's still a little bit of a push left, right? And then it speaks heavily against this quarter because you get a -4 and something like that, okay? This is going to happen in my theory, okay? So, you know, from the semantic point of view, right, you see partitions play a role, okay? And, you know, in the good old days, we thought this was nice semantics for questions. Of course, Ivano is sitting there, so I can't really say that anymore. I take it back, okay? But, you know, we're in an interesting ballpark, right? Or Lewis on aboutness, right? Of course, now we know we can do aboutness better, Truthmaker and so on. But, you know, that's an interesting thing. What I add here is the grades. That's sort of the new thing, right? Every partition cell comes with a grade. Instead of talking about the partition cells, I could also look at the little worlds, right? The little squares here. And, you know, if you enumerate them, you might think of that as a longish vector where each dimension corresponds to a possible world. And on each dimension, you have a number sitting there, right? On all the worlds that are in that partition cell, you have a 3 sitting there. So 3, 3, 3, 3, 3. And then you come to these worlds, -3, -3, -3. So you can also think of these epistemic forces as being represented in terms of vectors, okay? And it doesn't matter for my theory whether you view them in the one or the other way. Okay, so let's now think about these things a bit more systematic, shall we? Okay. Now, I told you reasons are facts that exert epistemic forces on an epistemically ideal subject's belief function B. So these are the ingredients that I have, right? So there will be the reason, that's a fact, viewed off in a context. It exerts an epistemic force, that will be my graded partitions or vectors that I just mentioned. And they are going to push your subjective probabilities around, okay? And the theory is really about that kind of interaction, how these parts fit together coherently, okay? I don't have original things to say on the fact side, and I don't have original things to say on the rational belief side, okay? So facts will be, in my view here, parts of the actual world, okay? And they have a mereological structure, so there's parthood, fusion. This will be the aggregation, okay? The aggregation of reason will be the fusion of facts, okay? And overlap, okay? And I have standard assumptions, you know, pretty much like Kit would have in his state spaces or even a bit earlier in the fact frames. Okay, so I'm building on that. Okay, I add a little bit of assumptions, so there's a kind of distributive law here. Okay, if you want to know more about that, ask me later. And I assume that there is a least sort of trivial fact that's part of every fact whatsoever, like a 0 fact. Okay, and the non-overlap of facts will be particularly interesting later. Okay, and I'll say 2 facts do not overlap if the only part that they have in common is this trivial or empty fact, okay? So if there were sets, their intersection would be like the empty set, right? That's for me non-overlap, okay? And the belief functions on that side will be regular probability measures, okay? So standard probability measures, finitely additive, again, no surprises. And regular means that the only proposition that will get a 0 probability is the empty set, or the logically contradictory proposition, as it were, okay? And the idea will be that, my reasons are meant to be these little pro tanto reasons that sort of weakly speak in favor or against something. They push around your probabilities, but they are never going to rule out anything sort of strictly or deductively. Okay, that's also interesting. Another interesting reason for relation, deductive reason for, but it's something that we know how to handle in deductive logic. And probabilistically, it would be something like ruling something out completely. Okay, but that's not what I'm interested in here. I'm interested in this weaker form of reason for. Okay, and there it's nice that probabilities are never be set to 0 by anything. Okay, except of course the contradictory proposition, the empty set will always have 0. Okay. So the interesting bit is then how to relate these parts and especially to tell you more about these epistemic forces. So in order to make that story precise, I introduce primitives. And the first primitive I introduce is what I call the direct reason relation R. And this is this thing that made an appearance early on my slide, right? So the way I read it is X, that's a fact ultimately, right, is a direct reason of strength little r, that will be a real number, relative to proposition A, okay? And, in the simple cases, we will have R, say, will be positive, and then this is a reason for A. R will be negative, then it's a reason against A, okay? And for example, these reasons little x and little y that I had before, graphically depicted like this, I would write in the axiomatic system like this, okay? So x speaks for A with strength 3, x speaks for, scare quotes, right? Not A with a strength of -3. Okay? So these minus weights or minus strengths code really speaking against, okay? And the same for B here. So this is how this will look like in the axiomatic system, okay? These reasons that are depicted here are of an especially simple kind. I call them elementary, okay? So an elementary reason X relative to A and R is such that X speaks for A with a strength of R. This is greater than or equal to 0, and X speaks for not A with -R, okay? So if the reason is of that form, roughly speaking, it speaks for one half of logical space with a positive or non-negative number at least, and for the other half with the opposite number, sort of. That's an elementary reason, okay? But other reasons might be more complex. Complex reasons are ones that are not elementary. Remember when we had this fusion or aggregation of the two reasons before with the 4 partition cells? That would be a complex reason, okay? So they are particularly simple cases. It's like, in chemistry, right? So, elements are meant to be simple in a chemical sense, and these are reasons that are simple in the reason sense, okay? Now, actually, I'm suppressing parameters. If you know about the philosophic literature and reasons, right, they also normally don't make it explicit, but really, it's always a reason for a person, okay? It's a reason in a context of, of a possible world. Right? What is a strong reason? One possible world might be a low one with a small strength in another possible world. Also, it's the same fact maybe that inhabits different possible worlds, right? The context matters. And also the point of time might play a role, okay? So, this is very well captured in this big debate in the philosophic literature on reasons that's called holism of reasons, the context sensitivity of reasons, okay? It's there, but I'm going to suppress it in the axioms to make them look simpler, okay? So that's why I'm suppressing them. See, suppressed, okay? Okay, but it's there, right? And, for some applications, this might become relevant again, okay? Now, as I said, intuitively, every such reason imposes a kind of epistemic force on your degrees of belief, if you're the subject in question. And what do I mean by that? So actually, in the axiomatic system, I'm explicitly defining epistemic forces, the force of a reason, okay? But, for the sake of my talk, you can also think of it as a primitive term that is governed by some axioms, amongst which you find the axiom of epistemic force, which I write here like an abstraction principle. So think of epistemic forces as something that you can abstract from the reasons themselves, which are the facts. Okay, you abstract them out, okay? The reasons are facts in the world, okay? But the epistemic forces are abstract entity that you abstract out from these force from these reasons. And the axiom says X and Y, two reasons, two facts, right, have the same epistemic force, just in case they speak for the same propositions with the same strength. So roughly they have the same push, as it were. Okay? And you know, who knows, maybe the world is so nice that it's never going to happen, that two numerically distinct facts have the same force attached to them. But this is left open by this, but I'm just saying they have the same epistemic force if they make the same pushes, roughly speaking, normatively speaking, okay? And I take it to be constitutive of facts qua reasons, right, that they have these epistemic forces, okay? That's what makes them epistemic reasons, okay? You'll see that in action very soon, okay? Now, what's important is in this primitive reason relation R, I have these three parameters, some are suppressed, but what I don't make explicit in the axiomatic system, and because it's not there, is the agent's belief function, okay, her subjective probability measure, which I'm going to denote by a little b, but you know, it's not there, okay? And you might think that's strange because there are theories around in the literature where, you know, you would only be able to speak of reasons relative to, say, in this case, a subjective probability measure, but it's not what I have here. Okay, and the reason will be that the strengths like this R here will, as you're going to see, be functionally related to what's in the Bayesian literature is called the Bayes or odds factor. Okay, I'll explain later what that is. And these are known to be numerical representation of what is learned from the new evidence alone with prior probabilities factored out. So that's a quote by Carl Wagner. Okay, so you know, the strengths, in a sense, will be such that they will be invariant over belief functions. Okay, the belief functions are not needed to determine them because they are going to track on the Bayesian side a quantity where these prior probabilities are already washed out. Okay, and that will enable me not to have a fourth argument placed here with the little b, the agent's belief function. I can drop that. Okay, and that's nice because it will allow me to isolate a part of the theory that is independent of subjective probability measures, where reasons can take a life of their own, as it were, okay? And that's nice, I like that. In particular, if X is an elementary reason like the one I had before, right, speaking for A with a, say, positive R, then taking into account such an elementary reason will increase the subject's degree of belief in A, and the way it will be increased will be the same for all belief functions. Okay, now you might wonder, what does it mean to have the same way, right, of increasing? Well, I'll show you later. This was this business of Bayes factors and odds factors. Okay, so that's why you don't have a B here. But then, you know, say you have this X, it speaks for A and against not A, and now you say, Hannes, that's nice, but now I want to know how strongly does this reason X speak for some, you know, other proposition capital X that lies sort of orthogonal to the A and the not A, right? So the A overlaps, sorry, the X. This is your favorite proposition. You're interested in that for some reason, okay? X overlaps the A set theoretically, but it also overlaps the not A set theoretically. It's sort of orthogonal to the distinction that the reason does, right? So if I go back to my picture, the X might be, you know, some set here. It has something in common with the A and something in common with the not A, okay? Now then my theory will say, well, just with the R relation, I can't tell you how strongly little x speaks for your proposition, okay? Because the reason will be, this will depend in a sense on how strongly we weigh that part of x against that part of x. And the reason itself, the little x won't tell you because it's orthogonal to the structure of the reason itself, as it were, to the partition, okay? You need a weighing. And this weighing can only be supplied, in my view, by the agent's subjective probability measure, her belief function, okay? So while the R will be perfectly fine, and I don't need a little b as a fourth argument place, I will have a second reason for relation in my theory, which I call S, and it will have the agent's probability measure as a fourth argument, okay? And I'll call this doxastic reason. So X is a doxastic reason of strength little s, that's a number again, relative to proposition X, like the one that I just described, relative to the agent's belief function B, okay? S will not be a primitive, but is defined explicitly in terms of the primitives of the axiomatic theory later, okay? So the real action is with the R, but indirectly you also get sort of something that I call a doxastic reason for relation. Doxastic means that now the belief function plays a role, okay? And how do R and S relate to each other? If X speaks for A with degree R, according to the capital R relation, this will entail that the S relation holds with the same argument places, but for arbitrary B. So this is this kind of invariance across belief functions that the R encodes as promised. Okay, so one of the downsides, if you like, about my theory is that it comes with two reason for relations, where originally you might have hoped there is just one. Okay, but as far as I'm concerned, that's how it goes when you rationally reconstruct or explicate something, right? So things that intuitively sort of were one concept all of a sudden bifurcate into two, and I'm happy enough to go there, to be honest. Okay. All right. So also in the literature, this is not totally unheard of. Okay. So Pollock back then had a distinction between non-doxastic and doxastic reasons. Okay. So the non-doxastic reasons is more like my R relation, and the doxastic reasons, that's more like my S, doxastic reason for relation. Okay. And in the more recent literature, you find a distinction between non-derivative and derivative reasons, right? Something like intrinsically good versus, relationally good or so. That's also related to what I have here. And in the Bayesian literature, right, when people were not, dealing with conditionalization, but generalizations thereof, right? Like Richard Jeffrey with the Jeffrey update, okay? So that's a situation where the evidence is not a proposition on which you conditionalize as a good Bayesian, but rather the update is you learn a proposition so that after the update, it will have a certain strength of 0.9, right? But not 1. Nothing has been ruled out completely, okay? Then what you find in that situation, Jeffrey recommends in this kind of update, this is maybe the new probability, the 0.9 of this thing that you want to end up having a probability of 0.9 of, right? This is the probability of the negation, and with that formula, you get the probability of arbitrary propositions X then, okay? But as you can see here, there's two kinds of mechanisms involved. One is you get direct probabilities that are given by the evidence itself, right? The 0.9 for the proposition A. There's no calculations going on, right? This is done by the evidence itself, by its impact on you, right? And then for the other propositions, you get them sort of inferentially, as it were, through the formula that involves conditionalization, right? So this direct assignment of probabilities, that corresponds to my R relation, the direct reason for relation, okay? And the indirect derivative or inferential sort of, calculation of probabilities, that corresponds a bit to my S relation. Okay, so you see similar moves have been made, mutatis mutandis, okay? Now, there's other versions of that update. So famously, Hartree Field in the late 1970s suggested a reparametrization of Jeffrey update. So he presented Jeffrey update in a different way, okay? And so what he didn't like was, I don't want the evidence to be of the form, this proposition should have 0.9 at the end. Rather, I want to have what he called an input parameter, a little alpha, okay? That would track sort of, roughly speaking, again, the oomph of the evidence by itself, right? What the evidence by itself does, right? Independently of the agent's prior, right? Because this thing is a kind of mixture, as it were, right? This 0.9 of maybe the old priors in a sense, and what the evidence does. And he wanted to separate out the contribution of the evidence by itself, right? And then he came to this reparameterization with a little alpha and a minus alpha here, okay? Again, there's something like direct and doxastic again, okay, analogy. But as you're going to see, that will be the very end of my talk, these input parameters that Hartree held, right, they will correspond to strengths of reasons, according to my theory. So one of the things that I'm able to derive later with all the axioms in place is that rational belief revision by reasons is a field update. And the input parameters that Hartree had are the strength of the reasons, okay? And that will complete the full Bayesian picture of my theory. Okay. Now, more about the aggregation of reasons, the putting together of reasons. Okay. Now, in aggregation, in a sense, will be perfectly straightforward. You have two reasons. Remember, they are facts, and facts have a mereological structure. That's what I'm assuming. So aggregating them just means you take their mereological fusion or sum. Right. End of story. Simple enough. But now you want to know. Okay, interesting. But what are the strengths with which such a fusion speaks for a proposition? Does it maybe, if you're lucky, depend somehow on the strength that you got from the facts that are to be fused? Okay, and again, remember the driving idea was somehow reasons might add up if you're lucky, right? And in fact, that's what my axiom is going to postulate. Okay, but not for any old x and y's, but for non-overlapping facts, x and y. So take two facts and let's assume, merologically, they don't overlap. Okay, the only part that they share is the trivial fact that's included in everything. Okay, then if you put them together, roughly speaking, I will assume that their reason strengths for propositions add up. But now we need to make that precise, and that's what the axiom does. Okay. So on the left-hand side, we have the fusion, x fused with y. It speaks for capital X with strength T. And then the right-hand side says this is so just in case there are propositions A, B, and real numbers R and S, such that X, the one fact, speaks for A with R, Y, the other fact, speaks for B with S. X is the intersection of the propositional contexts, okay? It's non-empty, otherwise, this won't apply, okay? And the T number that you have here is the sum of the R and the S number that you have here. Okay, so ultimately, you get a sum up of strengths of reasons as speaking now in favor of the intersection of the propositions that they speak for individually, when you put them together and they don't overlap. Okay, now, why do I assume that they shouldn't overlap? Because otherwise, there's the danger of double counting. Right, you might have two facts, say they overlap, they have something in common, and when I then add up the two, there's the chance that I, count the joint part, the joint non-trivial part that they might have twice, right? And that would be wrong. It doesn't sound right. Okay, so that's why I want to avoid it. It's also like, think of physical objects that you put into the pen of a balance or a scale, right? Then we're lucky. Macroscopic objects are such that they don't overlap when we put them in there, right? That's why they add up. Okay, so that's what's behind this here. Now, there's a lot going on here. Let's just look from the right-hand side to the left-hand side. Okay, let's say X speaks for A with R, Y speaks for B with S. X is the intersection of the two of them, A and B. It's non-empty because one of my axioms is the contradiction. Nothing speaks for it. Okay, nothing is a reason for a contradiction. Okay. Okay, and let's say how we get to the left-hand side. So there's another axiom that helps us a little bit to get a feel for what's going on. It's called the axiom of right strengthening. And it says if X speaks for Y, then it speaks for every non-empty subset of Y. So if X speaks for a proposition with a strength, right, it doesn't differentiate between different parts of that proposition. It speaks throughout the proposition with that strength. And therefore, for every non-empty subset, it speaks with the same strength. Okay? So this is another axiom that I have. If you remember good old confirmation literature, Hempel, that sounds a lot like Hempel's converse consequence condition, okay? And you might worry about that like Hempel did, but I think wrongly so. It's perfectly fine as far as I'm concerned, right? And if I remember correctly, Stephen Yablo in the Aboutness book, he says, people were sort of angry at converse consequence like Hempel, but not for the good reason, okay? And I think that's right. Something like this is fine. By the way, you don't get that for the S relation, but I only have it for the R relation, okay? And there it's perfectly fine as far as I'm concerned. So what this means is, if you're in the situation like here, X speaks for A with R and Y speaks for B with S, okay? Then really X also speaks for the intersection with R, right? And Y also speaks for the intersection of A and B with S, right? Because the intersection inherits the strength R from X and inherits the strength S from Y, right? So two facts impose their strengths on sort of the same proposition, as it were, right? And now the question is, if you add up the reasons, as it were, you sum them up merologically, what's the overall effect, right? It's a kind of superposition of the little r and the little s, but what's that function? And the axiom says, well, it's the addition function, okay? And now you might raise your arm, rightly so, and say, why? It could be something else, who knows, right? Absolutely, and I don't think you can justify that axiom of aggregation just by looking at itself, but you have to look at it within the overall theory, okay? And then it will be justified, I think, amongst others, in a Bayesian way, because it leads to the right sort of Bayesian update. That's this field update that I mentioned before. If that didn't happen, I would worry, okay? But I think it makes overall for a very neat, nice, smooth picture with the Bayesian story, okay? So I think it will ultimately have a Bayesian interpretation, okay? So what happens is, if what we depict here is the epistemic force of X, and we depict here the epistemic force of little y, we fuse them, let's assume they don't overlap, okay? then the fusion will distribute its strengths like that over logical space, okay? And you get the 3 plus the 1 is a 4, and the -3 plus the 1 is a -2, and so on. The numbers add up, okay? And you get the quarters here by taking like the intersection of this thing with this thing, or this thing with this thing, then you're down here and so forth, okay? So this is just the graphical representation of what I had in my axiom. And again, if you looked at it sort of in terms of vectors, this would be a vector, this would be a vector. What's the epistemic force of the fusion? You can't see it here, right? But the force of X fused with Y is the force of X plus the force of Y. Sort of what's fusion for the non-overlapping facts is addition of vectors for the epistemic forces. Okay, there's a diagram that commutes, sort of technically speaking. Okay, that's what's happening. Okay, and indeed one can derive from the axioms, okay, I haven't given you all of them, but that you can represent the epistemic forces of epistemic reasons as these graded partitions or real valued vectors, right? The dimensions are the worlds, and the numbers are, you know, how strongly the reason speaks in favor of that world. And the epistemic force of the aggregation of non-overlapping reasons can be represented as the sum of the representations of their epistemic forces. So you get an additive picture of reasons as promised, as it were, right? Because remember, that is what I wanted to have. That's the metaphor, you know, that Chef Forti was rightly worried about, okay? Now I should say, you know, there is arguments in the literature against the additivity approach, okay? And I'll deal with one of them very, very soon, okay? But there is more, and I can't cover all of them. So I should mention Federico Faroldi's excellent work. So he has some impossibility results, measurement theoretic results, okay? And I don't think they undermine the theory, okay? And, you know, if you're interested, ask me in the Q&A, but I can't go into that, okay? And he also has some other challenges, and, you know, again, I have some additional slides. If you are interested in the Q&A, you could ask me about that. I can't go into that. I'm just saying, you know, there are challenges, but I think the theory meets the challenges. One challenge, at least, I will deal with in a sec, okay? And also, I was very much helped by Federico's remarks the last time at the last event of this sort. So he was a great help. Okay, now, final bit. How do these epistemic reasons with their epistemic forces now relate to rational degrees of belief, right? The B function, the belief function. And the idea is, right, something like a good old Carnapian total evidence principle, right? So there the idea was, well, if you want to rationally update, you better take into account, you know, the totality of evidence or totality of relevant evidence that's available to you, right? If you only looked at part of it, you might get the wrong sort of probabilities out, right? That was the idea, okay? So the corresponding requirement of total reason would mean, right, if between 2 points of time, right, you have a subject, she should use the totality of the epistemic reasons that have become available to her in that period of time, right, to determine her posterior degrees of beliefs at the later time from her prior degrees of beliefs at the earlier time. Okay, so take into account the totality of epistemic reasons that have become available, right? That should sound perfectly plausible, I think. But the problem is, what does that mean? Right? What's the totality of reasons and how do I update all that, right? No idea. But fortunately, right, in our case, we can make it simple because you can just fuse up all the reasons that have become available to her, right? These are all facts. Take their mereological sum, voila, you have one big fat reason, as it were, right, that emerges from that. So once I have a theory that tells you how to update your belief function on a reason, then I know how to do that because I take all the little reasons that become available, fuse them into one, and then the theory will tell me what to do. And that's what I'm going to do, okay? So really a totality of reason will be the aggregation of all the epistemic reasons that have become available to her. We know what that is, I already told you. And now I'm going to tell you how to rationally revise your degrees of belief in the light of a reason, like the one that we might get from aggregation, okay? Now, this is, you know, all a bit non-standard, right? The Bayesian normally doesn't update on reasons. They don't have reasons in their theory, right? And the reasons people in the philosophy literature, they don't deal very much with update or revision, right? It's more like you have beliefs and they're supported somehow, but there's not much about the dynamic picture. So again, this is what I meant when I said we will need some tolerance on both sides, okay? But, you know, we're tolerant people, right? So should be fine, okay? So how should you update on reasons? Final bit of the theory. Now, in order to explain that axiom, I need to have some Bayesian terminology. Bayesians are keen on odds, right? Think of betting, right? So these are these ratios. Like the one here, you might have a new belief function after update. Then the new degree of belief of A over the new degree of belief of not A, that's the new odds on A, they would say. Okay, so you compare the probabilities of A and not A with each other. You can also do that in terms of the prior belief function B of A over B of not A. That's the old odds on A, right? Okay, and then what you can also do is you take the new odds of A over B, or let's make it simple, of A over not A. You take the new odds on A over the old odds on A. And that's what they mean when they speak of an odds factor or a base factor, okay? And Bayesians are really keen on these odds and base factors. And one reason to see why that is if you think of conditionalization as a kind of standard update procedure for Bayesians, right? And you look at Bayes' theorem, then you can rewrite Bayes' theorem in this form, where you say what's happening in an update is you really update odds. Okay, so you have your old odds like B of A over B of B. You multiply the old odds with a number that's happening in the course of conditionalization, and out you get the new odds after the update. Okay, and what's the factor? Well, that's this likelihood ratio. The probability of E given A over the probability of E given given B. Let's assume B is not A again, right? Then it's the probability of E given A over the probability of E given not A, okay? And that's this likelihood ratio. And then you have a form of Bayes' theorem, okay? And as far as I'm concerned, I think it's the nicest way of writing down Bayes' theorem. So what happens is when you update as a Bayesian via conditionalization, you have a specific way of updating sort of your odds, okay? And if you bring these odds here, the old odds on the left-hand side, then you would have the new odds over the old odds. That's the base factor. And the base factor would be this likelihood ratio. Okay, that's why they're interested in the base factor, because the base factor tells you how to revise by multiplication the odds, right? Determines that kind of quantity. All right, okay. So now I'm not interested in conditionalization, I told you, because my reasons are these little pro tanto reasons, right, that never rule out anything completely, right? It's not a strict reason for relation that I'm interested in or deductive, but this pro tanto reason for relation. So we will have soft versions thereof, but I'll still have something that you can put into that format. And this is the axiom of belief revision that I have. I've formulated here for revision by elementary reasons. Remember the ones that speak for A with a number and the opposite number for not A. There's a corresponding axiom where you can revise your belief function by arbitrary reasons, okay? But let's make it simple here, okay? And what the axiom says is you have your old odds on A, you have your new odds on A, and I write them like this. That's what you get by revising B, your prior belief function, by little x, where x is one of these elementary reasons, okay? And this star thing, the asterisk thing, that's a new primitive of my theory, and it denotes belief revision, okay? The revision of a subjective probability measure by a reason, thinking it has become available to the agent, okay? And how do you get the new odds from the old odds? Well, by multiplication. So this has the Bayesian format that we just had. That's nice, okay? But what's the number that you get? Well, as I say, up to a function and some constant here, it's the strength with which x, the reason, speaks for A, right? And minus r would be for the not A. So basically, right, instead of having a likelihood ratio here, I have a strength of a reason that's given sort of by the reason itself. Okay, that's the idea. And I put it into this Bayesian format. And really, there are some additional assumptions in the axiomatic theory, a non-triviality assumption and so, and it will actually allow you to determine what that function is. It's the exponential function. Okay, and what will happen is, right, so you see here f of 1 is greater than 1. Generally speaking, f of positive values are greater than 1. And so this will mean that if the strength here, the reason speaks for A with a positive value, this number will be greater than 1, and so the ratio will be changed in the way that the probability is shifted towards A. Okay, and if the strength of reason is 0, sort of in between positive and negative, pro and con, right? Then actually, f of it will be 1, so the odds are not changed because the reason doesn't speak for A or against it, right? Because it's 0, it's in between. And if the reason strength is negative, then through F, you get a number here that is between 0 and 1, which means the ratio is going to get smaller, which means the probability is shifted towards not A rather than A, because X speaks now against the A, sort of, and in favor of the not A. That's how this works, okay? And you can also now, once you have that function determined, represent the reason strength in Bayesian terms, and that would be its representation in Bayesian terms. And you can see it's a log likelihood ratio, if you think about it in a way. But now, if it was Bayes' theorem, as it were, okay? I'm almost done. So 5 minutes and then I'm done. Is that okay? So you can see up to sort of functional determination, reason strength corresponds to logarithms of base factors, right? That was our base factor that we had, right? So really the bridge that I get through the axioms, and then that's something that you can derive then, okay? It follows from the axioms, that the reason strength on the reason side correspond on the Bayesian side to logarithms of odds factors. And that's a nice quantity for Bayesians to have. So as I said, it is well known that Bayesians want to have a numerical representation of what is learned from new evidence alone with prior probabilities factored out. It's a staple of Bayesianism that ratios of new to old odds furnish the correct representation of the desired type. So, that's exactly what they're interested in when they want to measure what the evidence by itself does in an update. Sort of with the prior probabilities, washed out, as it were, okay? And that's why the base factors or odds factors are so important to them. And taking logarithms thereof is also not unheard of. That's what I.J. Good meant when he was speaking of weights of evidence, for example, okay? And that's what Hartree really meant when he was speaking about his input parameters, right? So you get a nice fit with that kind of literature. So I think these Bayesian insights ultimately lend support to the belief revision axiom because it has this Bayesian format. It shows why the direct reason relation is independent of the B, okay, because it's washed out. And you get a definition of the S relation ultimately by using the same format. And that's the final bit that I wanted to give you. So that's how the S relation is defined, okay? So again, looks very much like what I had before, right? You see, but if I go back here, this was just for A and not A. That's what the X speaks for directly through the R relation, okay? But say you're interested now in capital X lies orthogonal to the A, okay? Then you get something when you put in here the X and the not X here, okay? And the number that leads from this ratio to that, that's the one that I put here, and then I say they stand in the capital S relation. So indirectly, by taking into account how B sort of weighs possibilities against each other, you can then conservatively extend the R relation to all propositions whatsoever. And you always get a reason strength out, okay? That's how this works, okay? And this relates again to parts of the literature in a nice way. But I won't go into that, okay? And I want to conclude by showing you this in action. So this is an example from the literature of someone worrying about the additivity of reasons. So a typical kind of worrying example, okay? So this is from Chaim Nair. And so there are two people, John and Bill, are rarely found together. They dislike each other, okay? Think of two philosophers that you know in your department. They dislike each other. Easy enough to find, right? John and Bill, okay? And now you're wondering whether exactly one of them is going to attend the party that's going to happen. It's a strange question, but you're a logician, you like that, okay? Whether exactly one of them is going to attend, that's what you're interested in, okay? And now in this setting, finding out John will attend is a reason to believe that exactly one of them will attend intuitively, right? Because it's a reason that John will attend, and the prior beliefs make it the case, well, then probably the other one doesn't come, right? Because they dislike each other. So it's a reason that exactly one will come. Make sense? Yeah? Okay, and then symmetrically, right? Finding out Bill will attend is also a reason to believe that exactly one of them will attend, right? Because you get a reason that Bill will attend, prior beliefs, they won't come, then the other one won't come, right? So exactly one will come. But their accrual aggregation, putting them together, finding out that the one comes and also finding out that the other one comes, does not seem to be a reason to believe that exactly one come, but rather a reason that both come, right? So it doesn't add up, right? Worry, problem, and so on, right? What does my theory then predict in that kind of situation? Well, let's formalize it, okay? You have a prior belief function B, right? Where you sort of know that they dislike each other, okay? Then you have effect finding out John will attend, effect V, finding out Bill will attend. They don't overlap. Give me that, because sort of they're about different stuff, okay? And now let's see what's going to happen. So this is the prior belief function. So you see, This is the proposition John will attend a party. This is the proposition B will attend a party, John and Bill. And the probability here is small because they dislike each other. So it's unlikely that they show up. Both of them will show up, okay? And the rest of the probabilities I've distributed uniformly because we are not told otherwise in the story, okay? Now, finding out John will attend, that's a reason that speaks in favor of John will attend. Let's assume it looks like this. The numbers I've cooked up, okay? They are willy-nilly, but positive and minus, fair enough, okay? And then actually, I can prove a theorem that tells you what the resulting belief function is like, right? I didn't postulate that, but you derive that from the axioms, and it's this field update that I mentioned. You plug in the numbers, that's the new probability measure that comes out, okay? And as you can see in this diagonal, the diagonal corresponds to exactly one of them is going to attend. That's the diagonal, right? So exactly B or J, right, is going to attend. That's the diagonal. And you can see the probabilities are pretty high now, 0.8, 0.86 plus something. Originally, they were not so high, right? So you get support, as it were. That's, I think, what near means, okay? Now, what if we had found out that, Bill is going to attend? So this would be a different reason, V, different fact. We update on it, we get probabilities, they look different, but in the diagonal, if you sum them up, you again get an increase, right? Now it's because of this 2 here rather than what we had here, okay? So again, this speaks sort of in favor of one of them coming exactly, okay? But now, what if we aggregate? And there's 3 things that we can do now. We could take the B, update by U, update by V, right? Or we could take the B, update by V, and then by U. Or we could take U and V, aggregate them, then fuse them, and then update B by the fusion, right? And fortunately, my theory predicts that all of them amount to the same thing. So that's nice, right? Otherwise, okay, would sound irrational. I mean, psychologically, you can have these framing effects, but not if you're perfectly rational, okay? So it doesn't matter. So let's sum them up. That's the sum of the 2 reasons. You update, you get the probabilities, and in the diagonal, you get low probabilities, right? So that's, I think, what he meant when he said, now it's no longer blah, blah, and so on, okay? So I can reconstruct that. So that's funny. I constructed everything additively, right? I added up the reasons, but he's worried about additivity. So what's the problem? What's going on? And what's going on is, I think, or these reasons were speaking for certain propositions, right? Through R directly, J, B, and so on, these intersections. And you all get that additively for them, and you express it in terms of the R relation, and you have the additivity axiom there. Fine. But what Nair meant was not any of those. He meant this funny proposition that is sort of disjunctive in nature, as it were, right? The diagonal, right? But none of these guys here was speaking in favor of that directly, right? This is something where the prior probabilities enter the picture. So the R relation is not the one to check, but the S relation is the one to check, okay? The message is the R relation is perfectly additive and no worries whatsoever emerge, okay? And I only postulated additivity for it, okay? For the S relation, I did not postulate additivity, and it's better so because if you plug in the numbers, you see that the numbers don't add up for the S relation. So S is not in generally additive, where R is additive, okay? And that's my message. So I think these counterexamples in the literature that people give, right, they sort of, from my point of view, mix up the R and the S. But if you keep them nicely separated, no worries are emerging, okay? And, the final observation is belief revision is actually done by belief update according to Hartree field. Okay, that's the field update, and it's something that you derive. So that makes the Bayesian story sort of complete. We've started in the reasons literature and ended with Bayesianism. Okay, so what has been achieved? I hope I've given you a rigorous axiomatic theory or parts thereof. It sort of resembles the pre-theoretic picture, avoids the problems in the literature, is fruitful by building this kind of bridge between the theory of reasons and Bayesianism, and sort of justifies thereby the process of arguing by adding up reasons. And that should be good news, because remember the typical philosophy paper that you might write? Sometimes we give cool deductive arguments, right? And we all cherish that. But more often than not, we really give arguments where we have a thesis and then we have a little bit of a consideration that speaks in favor of it, and another one. And we sort of in the hope that from the viewpoint of the reader, they're going to add up, right? But, it would be bad if that methodology was really corrupt, right? But it's not. So at least that's what I say, okay? But one needs to distinguish direct and doxastic reason for. And there's lots of potential, I think, for extensions and applications. And ultimately, I want to plug this in sort of on the on the meta-linguistic semantic side and use that as a semantics for my epistemic reason for ascriptions, and something like that for practical reason for ascriptions too. Thank you.